Now, let's talk about the relationship between differentiability and continuity. Here's an important theorem. If a function is differentiable at a point, then it is continuous at that point. This means that if the derivative exists at a point, the graph cannot break, jump, or have a hole there. However, the reverse is not always true. A function can be continuous but not differentiable. So remember this key idea. Differentiable implies continuous, but continuous does not always imply differentiable. Now, let's look at these graphs to see situations where the derivative does not exist. Remember, the derivative represents the slope of the tangent line. So for a function to be differentiable, we must be able to draw one clear tangent line with one slope. If we cannot determine one single slope, then the function is not differentiable there. Let's look at this point. Notice that the graph changes direction very sharply. If we approach this point from the left, the graph has one slope. If we approach from the right, the graph has a different slope. So we cannot draw one single tangent line at this point. Because of that, the derivative does not exist here. This situation is called a corner. Now, let's look at this point. Notice that the graph jumps from one point to another. The curve ends with an open circle, but the function value is actually a different point above it. That means the graph is not continuous at this point. And remember what we said earlier? If a function is differentiable, it must be continuous. Since the graph jumps, the function is not continuous. Therefore, the function cannot be differentiable here. Now, let's look at the graph on the right. Near this point, the curve becomes very steep. It keeps getting steeper until the tangent line would be straight up and down. That would be a vertical line. But vertical lines do not have a defined slope. Since the derivative represents the slope of the tangent line, the derivative does not exist at that point. Let's look at the bottom graph. Near the center, the graph starts wiggling back and forth very quickly. As we move closer to that point, the graph keeps changing direction again and again. Because of that, the slopes never settle to one value, so we cannot determine a single tangent line here. That means the derivative does not exist at that point. Now that we have seen these examples, let's summarize. A function fails to be differentiable when the graph has a corner, like the graph of absolute value of x. The graph has a vertical tangent line. The derivative limit does not exist because slopes change direction. A function must be continuous and smooth to be differentiable. So remember these key ideas. If a function is differentiable, then it must be continuous. But a function can be continuous and still not differentiable. A function is differentiable when the graph is continuous and smooth.